Hello student, you're welcome to the GMAT 41's lesson class today. I hope you had a wonderful time at school. It's really good to meet you once again. So today we'll be having a wonderful time with this topic. Have this on the board: data collection, interpretation, and presentation. Honestly, this is going to be a wonderful class, okay? We will take a tour, alright? What do I mean by tour? We would go around to get data, alright? We would collect information and interpret the information we collected. We'll also present them using the tools, the things we use to present, the things we use to show the information, the data that we collected and interpreted. Now, to start with first, I would like us to know what is data. And I'm going to put it in the simplest form for you to understand. But first of all, let me say this. It is not the data that you used in downloading, alright, this video to watch. That's not the data we are talking about, okay? Here in mathematics, the word data simply refers to collection of information. I take that again. Data is a collection of what? Information. Someone may choose to get information about a particular thing of interest. Maybe you want to know how old your mates are, okay? That is your classmates, and then you start asking them one after the other. You may try that. Maybe when you go to school the next time, ask some of your classmates, how old are you? Listen to them as they tell you their age. You may also collect information, which we refer to as data, about other things. For example, maybe the kind of food that your classmates love the most. You can decide to ask them, hello, Irene, what is your favorite food? Hello, Johnson, what is your favorite food? What about you, Musa? What is your favorite food? Chukwunaza, what do you like eating most? Ade, what is your best food? Now, when you ask these questions, whatever they tell you, you can put them down. Maybe some may tell you, I like rice. That's my best food. Some may tell you, I prefer yam. Another may tell you, I like swallowing, akpu, okay, or gari eba, fufu, whatever they tell you. You can put down those things. Write the name of that classmate of yours. Beside it, write the food that he or she loves the most. Does that make sense? When you do this, what you've done is simply to collect information, and that is what data is, as we are about to learn here. When you collect information, it is always best to organize that information. First of all, you have to interpret it. Then you present it in a way that is well organized, so that if you call someone, please come and see the information I collected about this group of people. Or maybe if you get that paper, you wrote this information, and then you gave it to somebody. If the person picks it, the person will look at it, and immediately the person can understand what you gathered, the information you gathered. The person can easily tell the meaning of that. And that is the most important thing we are going to do in this topic. How to interpret the information, the data that we collect. Is that okay? And then how to present them. Alright, students, I've told you what data is, as we are going to study here. I've also told you that it's important after you collect information, alright, you should be able to organize them so that someone can easily understand the information that you collected. One question that could be going through our mind now is, okay, why are we even collecting this information? Why are we gathering this fact? This idea, why do we need them? Why are we getting them? I'm going to tell you something very important now. Most of the problem that are being solved in life today, most of the challenges that are being solved are as a result of gathering of data, gathering of information. I'm going to give you an example. Okay, let us quickly go to the classroom to help you also understand why it is important for us to gather information, to gather data. Think about this. Your teacher may decide to gather information about the size or the height of the pupils or students in your class. What could be the reason for your teacher gathering that information? Your teacher may need that data, the information about your height, maybe to solve problem about seating arrangement. Normally in your class, the best thing that should happen most time about seating arrangement is for people who are taller to sit at the back, so that others who are not as tall as they are can sit in front in order to be able to see the board very clearly. So your teacher may decide to say, okay, everybody sit up, let me measure your height so that I can be able to arrange you people in a better way so that nobody will complain that this person is covering my view. So do you see? The information about the height or the size, all right, of you pupils or students in a class may help your teacher to decide how to arrange the seating of your class. I hope you now understand how important this topic is for us. Okay, now I would like us to talk about the types of data. Types of data. There are two main types of data. One of them is called discrete data, and the other is called continuous data. What do we mean when we say discrete data? A discrete data is a data that can take whole number as its value. For example, when you get information about age of pupils or students, or you get information about, let us say, the number of pupils or students in a class, such information, age, number of pupils or students, it's actually a discrete data, because the value of age or the value of number of people is always a whole number. I can say, okay, you are 12 years old. You cannot say you are 12.3 years old. We don't say that for age. Age usually takes whole number. Is that okay? You are 12 years, you are 13 years, you are 9 years, you are 10 years. What about the number of students or pupils in the class? Somebody can say, okay, we are 10 in our class. We are 15 in our class. Although in my class, we are 27. You cannot say we are 27.2 or you say we are 15.7. We don't use decimal number for such information. So such information that takes only whole number value is what we call discrete data. Now I'd like to talk about continuous data. This one now can take decimal numbers or range. Example, when you gather information about the height of pupils or students, alright, when you gather information about weight, I can say my height is maybe 5.2 meters. I am 5.2 meters tall. Okay, I am 3.7 feet tall. Alright, one can say, okay, my weight is 70.5 kg. You see that in each of these numbers I mentioned, I used decimal there. So any information or data that allows you to use decimal number for it. They can also appear in terms of range. In terms of range, that is from one number to another number. For example, say from 5 to 10, 11 to 15, 16 to 20, that's a range. Are you getting? A range is something that has lowest and highest value. Continuous data also can take such type of value. Do you understand what I've just explained? Do you have any question? If you have any question, please quickly send it down, alright? It is now time I am going to teach you about the tools we use in presenting data. We call them statistical tools. Remember, this topic as a whole has the name statistics. So statistics tools, the things that we use in presenting our data. That's now what I am going to teach you. As a student, you have tools that you use in carrying out your work, that you use in working, both at school and maybe when you come back home and you want to study. So can you tell me one of the tools you use as a student? Alright, that's good. We have your pen, your pencil. We talked about mark set, ruler, your notebook. Does that make sense? What about your bag that you use in putting all these other tools? In the same way, when you are learning statistics, data collection, interpretation, and presentation, there are tools we use for collecting data, for interpreting data, and for presenting data. These tools that are used for data collection, presentation, and interpretation are known as statistical tools. And so the question is, what are these statistical tools? Please come with me. Let me show you these tools. We have them written on the board, okay? One, we have frequency table. We have bar charts. Another one is histogram. We have frequency polygon. We have pie charts. And we have the one we call cumulative frequency curve, also known as ogive. These bar charts and histogram, they are similar. The only difference between bar chart and histogram is majorly that for bar chart, we usually use vertical rectangular blocks for them, okay? Stands like this as we draw the graph. I hope you're following. Bar chart, the rectangular blocks we use in drawing it, there are spaces between them. In fact, I'm going to show you how it looks like. So usually we have something like this. Then for bar charts, you see rectangles drawn this way. The rectangles will not touch. They won't touch. So this is your bar chart. This is your what? Bar chart. Let me write it as in BC. Then histogram is still similar to bar chart. The only difference is that in histogram, the rectangles will touch each other. So this one is histogram. Let me write it as HG. Why I'm saying this is that when you know how to deal with one of them, if you understand one of them, then the other one is no longer a problem, okay? Frequency polygon, we get it from histogram. Once you are able to draw your histogram, you can get your frequency polygon. For example, this is a histogram I said. If I get the middle of the rectangular bars, the middle of the rectangles, the rectangular blocks, okay? And then you join the middles. You join the middles like this, okay? That gives you what we call the frequency polygon. What about pie chart? Have you heard of pie chart before? Pie chart there, we use circle. Is that okay? Now, I want to quickly tell you this place. Because when we start dealing with pie charts, it is expected that you have this knowledge. Know that the angle at a point or angle in a circle is equal to 360 degrees. Store this information in your brain now. Angle in a circle or angle at a point is equal to 360 degrees. We will need that a lot when we treat pie charts. So these are 6 of the statistical tools you need to know about, okay? We use them for data presentation. I would like us to start with frequency and frequency table. We will define frequency, we'll also define frequency table, then we are going to look at an example based on information we gathered about the age of pupils in grade 6. What is frequency? On the board here we have the definition of frequency. It is simply the number of times an item occurs or appears in a distribution. When we talk about distribution, it's simply the data that we gathered, the information that we gathered. Now, the number of times a particular item appears in this distribution is what we call frequency. As a quick example to help you understand this, let us assume that you asked your mate about the food they like the most. Is that okay? Then maybe they started responding. One tells you that he likes gari, the other one likes rice, another person said that likes rice, another one says he or she likes gari, another one says maybe he or she likes indomie. Now, what I just said, how many times did gari appear? Twice. What about rice? You notice it's twice. What about indomie? Once. So the number of times each of these items appear, gari, rice, indomie, that number of times is what we call the frequency of the items. Is that okay? That is good. Now let us move on to frequency table. What now is frequency table? The definition is here on the board. As simply as you heard the name, table, frequency table. It is a table that shows the frequencies of the items in the given distribution. We have an example of it on the board here. This is how the table looks like. Okay? So the table will have the item you are dealing with, and then the number of times the item appeared. For example, going back to our rice, gari, and indomie example, you notice that indomie appeared once. So the frequency of indomie will be 1. Gari appeared twice. The frequency of gari will be 2. Rice appeared twice. The frequency of rice will be 2. So that is just what your frequency table is. A table that shows the item and the number of times the item appeared. So simply a table that shows the frequency of items in a given distribution. I have this example on the board here, okay? We collected this data, this information from pupils in grade 6. We asked them about their age. 15 of these pupils, and this was the information we gathered from them. We had 12 years among them. We had 9 years, 9 years, 9 years, 10 years, 10 years, 9 years, 9 years, 9 years, 9 years, 10 years, 10 years, 13 years, 11 years, and 10 years. So this was the response we got, and we recorded the response down. Now we have decided to draw the frequency table for this distribution. We have decided to present this table for you. You see, the table makes the work well organized, just like I mentioned previously, of why it is important for us to interpret and organize data, so that when someone sees this quickly, the person will understand what you're talking about. Look at this data we gathered here. Here it is raw. What do I mean by raw? We have not interpreted it. If I give you something like maybe I write 12, 9, 9, 9, 10, 10, 9, it won't make any sense to you. Is that not so? But with this table now you see age in years, you know. The ages we have here are 12, we have 9, we have 10, we have 13, we have 11. So you pick each of the ages that appeared. Are you following, right? Now, this column is called the tally column. It is not compulsory sometimes. There are times you may draw your frequency table and you may decide not to put it. Are you getting me right? Now, what is the tally all about? If you come here, we have 12. How many times did 12 appear from the response given to us? You notice that 12 years appeared only once. So in the tally, you will put one stroke like this. Is that okay? Let us look at 9. 9 years appeared how many times? Let's count it and see. 1, 2, 3, 4, 5, 6, 7. Alright, so 7 times. It means that in the tally, you're going to have 7 strokes. And how do we present it? Now watch. After every 4 strokes, the 5th stroke, you cross the 4 you had. Look at it. 1, 2, 3, 4. The 5th one, you cross it. Are you following, right? So this is 5 now. Then 6, 7. This shows clearly that 9 years appeared 7 times. What about 10 years? Let's count and see. 1, 2, 3, 4, and 5. How many times did 10 years appear in the age distribution? The information given to us, it appeared 5 times. 10 appeared 5 times. So you come to the tally column, then you draw your strokes. 1, 2, 3, 4. The 5th one, you cross it. Remember, 10 appeared 5 times. Then if you check for 13 and 11, they appeared only once. Like I said, this column for tally, most times we don't see it. Sometimes we have a frequency table without the tally column. It's still okay. But this frequency column very important because it is this frequency that made this a frequency table. So what do we need to know about the frequency? Quickly, let's go. It's simple. 12 years appeared once, so you come here and write 1. 9 years appeared 7 times. You come under the frequency there. For 9 years, you write 7. 10 appeared 5 times, so you write 5 for the frequency of 10 years. 13 appeared only once, so the frequency means that 13 appeared once. You write 1 under the frequency for 13 years. 11 years is still the same, it appeared 1 time. So that is all about frequency table, how to construct your frequency table. Alright? Now, I did something here. This symbol means summation, that is to add all frequencies. Alright? That symbol you saw there. Let me show it now. Think something like this. Are you following? It's called summation sign. It means add everything. This F represents frequency. If you add all the frequency, you notice it's going to give you 15. And that is what I wrote on the board here. 15. What does the addition of all the frequency tell us? Once you add all frequencies, it simply tells you the total number of pupils that responded, that you asked question, that gave you answer. So from here, actually there were 15 pupils. There were 15 pupils we asked about their age. Quickly from this table we can get to know that there are 15 of them. If you count each of this age, count them. 12, 9, 9, 9, 9. Count these, you will notice that you get 15. So whenever you add all frequencies, it will give you the total number, are you following, of people in the distribution. Now, we are going to take a little journey, a tour. You have a video clip that is going to be shown right away. As you watch the video clip, we decided to get the video of, moving objects, vehicles, tricycles, alright, motorbike or motorcycle as you might call it. In each of the video clip as you watch, you have questions that will help you gather the data, help you gather the information of interest to us. Are you following, right? This is what you are expected to do. As you're watching the next video clip, once you see question, please pause the video, answer that question. You can get a rough sheet, answer the question. Are you getting me right? Play the video again. Once you see another question, pause the video, answer the question you have there. That is just what I want you to do from the next video clip you are going to watch. Do what I asked you to do because you will get an assignment from that video clip. And it is also going to help you to understand the idea of frequency. Yeah, so that is all you need to know much about frequency and frequency table. I hope you were able to understand all I explained so far about statistical tools and about frequency and frequency table with this example. Please, if you have a question, remember you can always send your question to us. Go to your platform for asking of questions and submitting of assignments and simply send your question to us. Is that okay? Remember to do that video clip assignment I asked you to do. Very important, and you are to submit the answers you wrote on that rough sheet. We want to see it. Are you following, right? As that prepares us for our next class. Make sure you do the assignment and submit.